Welcome everyone back to the second video here in section number 3. In this video, we're going to start combining these functions. We got pretty far with this power rule. We saw it was very powerful. But now what happens if you start adding functions or subtracting functions, or maybe you have a constant times one of these functions? We're going to learn how to take the derivatives of all these things. All right, and the claim is, here in this theorem, luckily these rules are exactly what you would expect, kind of like our good old limit rules, right? If you were kind of guessing, you would probably guess these rules. All right, so this first one, this is the constant multiple rule. It's when you want to take the derivative, right? So here I have the Leibniz notation, d dx. So I'm taking the derivative of some constant times a function. And this can be something like x squared or square root of x, or things that we know how to take the derivative of. So this is the Leibniz notation. Here it is kind of in this prime notation, right? We like to kind of shorthand this. And the claim is, well, the constant is just along for the ride. It's going to be c times the derivative of f. So you take the derivative of f and then you just multiply it by this constant. So basically the derivative really only applies here to the function. Okay, next up, this is the sum rule, right? So I want to take the derivative of f of x plus g of x, or in this prime notation, right, a little bit shorter. And again, it's kind of exactly what you would expect. We're going to take the derivative of f, we're going to take the derivative of g, and we're going to add them together. So you can just take the derivatives kind of individually, sum the results. And finally, the difference rule, again, kind of exactly what you would expect here. Here's the Leibniz notation. Here's the nice good old prime notation. It's going to be you take the derivative of f, the first one, you take the derivative of g, the second one, and then you subtract them. All right, let's apply these to some actual examples. So the first one, calculate out the derivatives for the following functions. All right, we have negative 7 times root x. So in fact, maybe even before I start taking the derivative here, let me go ahead and remind us, right, that root x, or the square root of x, is the same thing as x to the 1/2 power. We're going to use this a lot, so make sure you have this put to memory. All right, so now if I want to take the derivative of this function, well, I know how to take the derivative of x to the 1/2, right? From last time we saw this is going to be 1/2 x to the negative 1/2, using our good old power rule. And now, according to the constant multiple rule, since I know how to take the derivative of x to the 1/2, this constant, whatever it is just kind of along for the ride. So in this case, the negative 7 is just kind of along for the ride, and so we get negative 7 times this 1/2 of x to the negative 1/2. And of course, we can simplify if we'd like, right? The negative 7 and the 1 can combine to negative 7/2 x to the negative 1/2. And so there would be my final answer. All right, so that's an example of the constant multiple rule. Now down here, it looks like I kind of gave us a hard one. We actually don't have the sum of just 2 functions, we have the sum of 3 functions. And the idea is, well, we can just extend this. Again, we're going to take the derivative of each one of these things, and then we're going to go ahead and add them together. All right, first let me go ahead and rewrite this. Again, kind of setting up, let me go ahead back to my blue pen here. Let's go ahead and rewrite this, setting up to use the power rule. So instead of the cube root of x, I'm going to go ahead and write this as x to the 1/3 power. All right, this was not the derivative. This is just me rewriting the function, getting ready to take the derivative. All right, so g prime of x. Well, we know how to take the derivative of each one of these pieces, right? So this first one, x squared, the 2 would come down. You would have x to the 1. Or if you want, you can just write this as x. Likewise, for the second one, the 1/3 is going to come down. You're going to have x to the, and we need to subtract away 1, so this is going to be negative 2/3. And then finally, the derivative of 2x, well, this is, we can think of it a couple different ways, but this is a linear function right here, right? So the derivative is going to be the slope, which is 2. So you take the derivative of each one of these pieces, then we're just going to add the results together. There we go. That is my final answer. All right, one more example here. So we have h of x, and now it looks like we have some subtraction, right? And addition. All right, so it's a good combination of things. Again, let me go ahead and rewrite this function before I start taking the derivative. Right, when I have 5 over x, according to our rule, this is 5x to the negative 1 power minus x to the 1.7 plus 4. And I want to take the derivative of this. And again, we're going to take the derivative of each piece. Notice this one has an extra thing, right? So it's got the constant multiple rule. There's a 5 out in front. So again, the 5 is going to be along for the ride. Take the derivative of x to the negative 1, so the negative 1 comes down, and we get x to the negative 2 power. There we are. X to the 1.7, right? So the 1.7 is going to come down, and then I'm going to have x to the 0.7. And then the derivative of 4, right? Well, this is back from our first video. It is a constant, and so the derivative of a constant is 0. And it looks like between these first two functions I have subtraction. Between these second two functions I have addition. Although adding 0 and subtracting 0 is the same thing, doesn't really matter. And so let me take one more line to simplify. This is going to be negative 5, right, when I multiply these out. X to the negative 2 minus 1.7 x to the 0.7. I go ahead, highlight that as my final answer. All right, so as we can see, sums, differences, constant multiple rules, right, these are all right. But as you may have seen, right, we didn't have anything about a product of two functions or a quotient of two functions. And that's going to be our last video, and the claim is actually, unfortunately, the product rule and the quotient rule are more complicated than what we would like. So, I'll see you then.